and record and share screen. So hopefully you guys had a fantastic weekend. All right, so we're talking about piecewise functions today. I want to get started here. Sorry, you won't have to deal with my mustache too much longer, I don't think. I know it's hideous. You guys do have a small assignment tonight. Make sure that you guys are doing it and you ask questions. But here we go. So, I know for a fact that you guys did this last year. We're doing the same thing. We're just going to add on a little bit. And I know it's been a year since you've done this. So I'm going to go as slow as possible, but making sure that you guys, we move on. So we'll do all the A2 stuff, but we're also going to throw in the pre-cal stuff. So a piecewise function, all it is a function that's broken up into multiple pieces, which basically that's how we end up with graphs that kind of look like this. You know, it's going here to here to here to here, so on and so forth. So we are talking about each of these segments, and that's what makes it a piecewise function. Again, what a function is, a function's an equation where for each x you have exactly one y. Now, I believe that we've talked about that a little bit. But what is and is not a function, it's not a function if your x's ever repeat. So anytime you have like a circle, that's not a function because your x's repeat here and here. All right. What is a function, again, would be like a parabola. That's a function. An absolute value, whether it opens up or opens down. A straight line, these are all functions. It's not a function if I ever have any vertical motion like this, because that means that something's increasing and no time is elapsing. Okay. Now, and I'm going kind of quick over this, but let's go ahead and do this. This is your function or your y value. And let's talk about the qualifiers first. So I only use this equation if my x value is less than 0. I'm going to use this equation anytime my x value is greater than or equal to 0. This is actually very simple, especially once you kind of figure out how to read this. All this is telling you is when do I use these equations. So for instance, I can ask you to evaluate something like this, f of -2 equals. Well, all that's saying is, what's the value of your function when x is -2? Well, which equation do I use? Is -2 less than 0 or greater than or equal to 0?
It's less than 0.
So that means I use this equation and I'm just plugging this in. So 6 times -2 minus 1, -12 minus 1, which is -13. Now, what if I had something like this? F of 3, greater than 0 or less than 0?
Greater.
So because it's greater than 0 means I use this equation. So I type in 7 times 3 plus 2, which is 23. So I know a lot of times you guys are thinking, when am I ever going to use this in the real world? Well, I've got a good demonstration or a good example here is, so we just ordered uniforms for the tennis team. And it said if we order between 0 and 12 shirts that they were going to charge us $7.99 a shirt. If we ordered between 13 and like 25 shirts, it was going to be $5.99 a shirt. If we'd ordered between 26 and 50 shirts, it was going to be $4.99 a shirt. So in some extent, it would cost us less to order 27 shirts than it would to order 25 shirts because they dropped the price. So that's where this is coming in play, all right? So take a second and try these on your own. Same examples, just make sure you understand them. If you have a question, make sure you ask. All right. So any questions so far?
So we just plug the number into the equation?
And to the correct equation. So Michael, what this is saying is this is your value of X, so which equation do I use, the top or the bottom?
The top, right?
Yeah, the top, because it's less than 0. So I've got 6 times -3 minus 1. So my answer is -19. So that's why I'm just looking at this and seeing, and the qualifiers to see which equation do I use. So on the second one, which one do I use? The first equation or the second one?
The second one.
Yeah, because 7 is greater than or equal to 0. So 7 times 7 plus 2, and I get 51. Now, one that throws almost everybody off. Oh boy, what if f of 0? Which one of these should I use if x is 0?
Shouldn't you use the second one since it's greater than or equal to 0?
Exactly. So greater than or equal to 0 means I have to use the second one. So 7 times 0 plus 2, 7 times 0 is 0 plus 2 is just 2. Any questions? All right, so overall, this is not very difficult, but it is all about paying attention. So let's do this again. I don't know if you guys can see that. I'll try and drag it down. So write this down. And try it on your own. Oh, I missed something. Hold on. Okay.
Mr. Riley, I'm kind of confused on how those equations are set up.
Okay.
It's like only one of them says if.
Well, so whenever they do this, it'll be written a couple different ways. That's if, so I use if. So it really goes for each one, okay? So if, I only use this one if that, okay?
And then the 1/3 one, so if it's 1/3 if
If
X-
x is greater than or equal to 1. So I want to show you guys, I put this up here so that I could show you two different things. So let's go ahead and get started, especially if you've already written this down. So the very first one, I want to know the value when x is -6. Which one do I use, the top, the middle, or the bottom?
the top one,
The top one, because I only use this when x is less than or equal to -2. So I'm going to use the top one because it's less than or equal to -2. So 3 times -6 is just -18. Again, what about h of -2? Do I use the top one, the middle one, or the bottom one?
top one,
Again, because it's inclusive, it's or equal to, so that's going to be 3 times -2, which is -6. Any questions so far? The next one, h of 0. Is 0 less than or equal to -2, between -2 and 1, or greater than 1? Which equation do I use?
Middle one.
The middle one. 0 is in between -2 and 1, so I plug in 0 for x. 0 squared is 0, times 2 is 0, plus 1, it is just 1. Number 7, h of 7. When x is 7, well, 7 is greater than or equal to 1, so I use this. So here's the question, and this is the new part. Does this have an x?
no,
So that means it's a constant value. For any value greater than or equal to 1, they are charging a flat fee of 1/3, or it is just going to be 1/3. So people get confused. They're like, well, how am I supposed to know what this is? Well, when x is 7, I use this equation. There's no x, so it's just 1/3. That's it. If it was an x, I would have to plug it in. But because there's no x there, it's constant. It stays the same. Questions there. So again,
ever like a reason to use that if you ever like have an equation that falls into that one, it's always going to be the 1/3.
exactly, or whatever that value is.
Yeah. Okay.
So again, something like that would say, let's talk about like prizes or something. If you hit, in 10 seconds, if you hit, or a minute, if you hit 5 shots, you'll get this as a prize. If you hit between 6 and 10, you get this prize. But if you hit over 10 shots, well, it doesn't matter how many, you're just going to get this. That's kind of what that would mean.
So
Okay?
if there's no x, it's just going to be like that number. That
Yeah,
we said.
exactly, every single time. And you'll see another example of that here in just a minute. So that's the first thing that I wanted to show you guys, was what happens when there's no variable here. It's just a constant. So no matter what this value is, or the variable, if there's no variable, every single time it's going to be the constant. Now we've already talked about this, but I'm going to change it up. You see how I put that in there? So what is my value of h of 1? It's still going to be what?
1/3.
Exactly. Any questions right now? So the next thing I'm going to show you is this. What if I went back to my original problem? I wrote this intentionally, but I talked about it in reverse order. So here's the deal. If x is between -2 and 1, I use this equation. If x is greater than 1, I use this equation. But now what if it says, what's my value of h of 1? I need you guys to think here. If this is no longer inclusive, which equation do I use, if any? Does it fall into this one? Let's eliminate them at first. Does it fall into this one? Is 1 less than or equal to -2?
No.
Yeah, of course not. Is 1 in between -2 and 1?
No.
No, again, because it'd have to be or equal to, so I can't use this one. Is 1 greater than 1?
No.
So I can't use any of them. So it does not exist. Now, if it does not fit into any one of these circumstances, any one of these equations here, or inequalities here, then it doesn't exist. So mind the difference between greater than and greater than or equal to. Now it would be 1/3. If I took that off, now it doesn't exist. Any questions?
So the answer to H1 is 1/3.
Well, if it was or equal to, and that's what I wanted you guys to really follow. So if it was like this, if it was greater than or equal to, my value would be 1/3. If it's just greater than, and this no longer fits into either one of these equations or inequalities, then it doesn't exist. Okay? So that's kind of what I was showing you guys both ways. And I made this slide actually last week, so I'm not sure what's next. Yeah, that's all for evaluating. So my whole point of this is to make sure you pay attention if this does not fall in. So that H of 1, if 1 doesn't fit in here and it doesn't fit in here, then it doesn't exist. But also be careful for or equal to. All of a sudden, if I would have plugged in or had it or equal to right here, now I'd have to use this equation. That's all I was trying to show you guys. Does that make sense?
Yeah.
Okay. Now let's talk about graphing these. Again, I don't know who your Algebra 2 teacher was last year, but I know this was part of it because I actually just went over at my Algebra 2 classes last week. But graphing piecewise functions. Oh, actually, you guys don't do it. This is only an x thing. So if you took 2x, you should be good to go with this. So it says make tables for points. I'm going to show you guys what this means. Again, and this doesn't matter if it's f of x, g of x, h of x, whatever. This is your function, your g function. So what this does, how you do this is, I only use this top equation if what? If x is less than or equal to 1. By the way, I'll give you guys a chance to write this down. I realize I'm going fast. My apologies. I always kind of talk fast anyways, and online with the delay and the participation and some of that stuff, I feel like I'm going twice as fast. So if I start going too fast, just slow me down. All right, now I'm going to take this chance, kind of look at your faces here just a little bit. See a lot of people still writing. A lot of people have their screens off, which is fine, but if I call on you, I hope you are ready to unmute. All right, so here we go. It says make a table for the points. The first thing I need you to do is make sense of this problem. What points do I use? So I'm going to make 2 tables, and it's always going to be x and y. So if I look at this, I only use this top equation if what?
X is less than or greater to greater than 1.
Less than or equal to 1. So it has to be smaller than or equal to 1. Whatever this is, I need to mind this while I'm making my tables. So I want all x values less than or equal to 1. So I have to start with 1, and then I need another value that's smaller than 1, because I want to only use this when it's less than or equal to 1. Well, give me a
Zero.
value that's smaller than 1.
0.
Perfect. And plug them in. If x is 1, 3 times 1 is 3. If x is 0, 3 times 0 is 0. Now I need you guys to watch this, please. When x is 1, y is 3, and I'm going to put a little dot here. Should that be an open dot or a closed dot? In other words, should it be open or should it be filled in?
Should be filled in
Why, Devin?
because it's greater than or equal to.
Exactly. So that should be a closed circle because it is or equal to. Then I've got 0, 0. And remember, this is not going to be a straight line. I can only use this when x is less than or equal to 1, which means this is a hard stop. It's a stopping point, and I keep going down in this direction. So I only use this when my x is less than or equal to 1. Do not put an arrow here. It is a hard stop. Now I'm going to kind of change the game just a little bit here, but let's do the second one. Again, I'm going to make a second table, and I really only need a couple points. I always, always, always start with this. So I start when x is what?
Greater than 1.
Greater than 1. I still put that as my first point. Now, as soon as I write this, is it going to be an open circle or closed?
Open.
And how do you know it's open?
Because it does not include 1.
Exactly, because it's not or equal to, and it doesn't include 1. And I want all my x values greater than 1. So like 2, 3, 4, 5, whatever. So if x is 1, or if it's greater than 1, we're going to start with this. What's my y value? So this is kind of like that plugging in again. Is there anything to plug in for?
No.
No, so it's constant. So no matter what, if x is greater than 1, it's going to be 4. So when x is 1, y is 4, and we already said open circle. If x is 2, y is 4, x is 3, y is 4, no matter what. And I only want that for the values bigger than 1. And we are finished. That's a piecewise function. Any questions?
So how do you necessarily like know what to plug in at the y? Like just the ones before the variables?
So, okay, so start with the x's, and you're always going to start with what's right here, whether it's equal to or not, okay? So that's going to be your first point. And your second point, you have to mind this. So if it's less than or equal to 1, then I need something on the left side of 1 or smaller than that. If it's greater than 1, I need something bigger than that. And I think that'll make sense in the next slide. I hope I didn't go too fast. So let's go back and do this again. Now make a table for the points. This one, we've got 3 different values, right? 3 different equations. And I apologize ahead of time. I'm going to see what the next problem is. Yeah, that's it. I thought this was the last one. So I had a third example up here of graphing, but I also didn't know how much time we'd have, so I took it off.
I just
Now,
want to make sure. So, like, when you plot your points, whatever way your arrow, like the line goes, that's the only way the arrow will go, right?
exactly. That's exactly right. Now, there's a little something different with this one because I would say my x's have to be between these two. Now, I'm gonna tell you again when we get there. But this is the last problem, and then we'll be finished. So let's do this one at a time. So I only use this equation when my x's are what? Less than or equal to -1. So what number do I have to start with my x's? Somebody.
-1.
-1. Not 0. I always, always, always have to start with that value. I don't care what the sign is. I have to start with that value. So -1, and is that going to be open or closed?
Closed.
Closed. So I'm going to write, let me change the pink here. I'm going to write closed at this point. I'm just doing that for myself. Then what's a value smaller than -1?
-2.
There you go. Now, some people start to go too fast or they don't think about this and they'll say something like 0. But remember, I want on the left side or smaller than -1. Now let's just plug these in. When x is -1, 3 times -1 is -3 plus 1 is -2. That's closed. When I plug in -2, 3 times -2 is -6 plus 1 is -5. So that's a hard stop right here. Ah, that's a terrible line. So it's going to look like this. Any questions? So I'm going to underline that in pink. The next one I'll do in blue. Now this one gets kind of ugly, and you might need your calculator for this. But I'm only going to pick 2 points for the second one. What 2 x values do you think I'm going to pick? Actually, I'm going to pick 3. I'm going to pick -1. I'm going to pick +2. So I have to choose them both. And what's a value, a good value that you'd like to see in here? Would you rather plug in 0 or 1?
1.
I heard 1, but Teddy, I'm going to argue with you here just a minute. If I plug in 0, it's going to kind of give you a vertex, and it will be easier. So if 0 is ever an option, try and choose 0. Now 1 would be fine too. In fact, some teachers might say this: if it's between -1 and 2, I want you to go ahead and plug in all of the values in between -1 and 2. So -1, 0, 1, and 2. I'm not trying to make you guys do more than you need to do. But I want you to see what this looks like. So real quick, with this -1, do you think that -1 is going to be open or closed?
Close. Oh, open.
Open. And do I think this 2 value is going to be open or closed?
Closed.
Closed.
Now let's plug these values in and see what we've got. -1 squared is 1 times 1/2. So at -1, I'm at a half and it's open. Plug in 0. 0 squared is 0 times a half is 0. Plug in 1. 1 squared is 1 times a half is a half. Plug in 2. 2 squared is 4 times a half is 2, and that's closed. You guys learned in Algebra 2 anything squared, it's a quadratic, it makes a parabola. But it only makes a parabola in between -1 and 2. Open at -1, closed at +2. And then the last one, I don't really even need to make a table. I want my x's greater than 2. So is that an open circle or closed?
Open.
And when x is 2, I will go ahead and make a table. You don't need to. So x is greater than 2, like 2 and 3. No matter what I plug in for x, as long as it's greater than 2, what's my outcome? It's just 1/3.
1/3.
So I've got 2, 1/3. 3 is 1/3. 4 is 1/3, so on and so forth. There you go. All right. Now, we are almost finished with class, almost. This is already up. You've got, let's see, 6, 7, 8. You've got 8 problems to do tonight. It's up here. I want to show you this. Your home page looks a little different today, and by the way, it's going to look even more different tomorrow. I'm going to leave this up here for today, but if you still need a graphing calculator, please, please, please take the time and read this. So we are having a pickup outside of door number 2 at the high school tomorrow, and I believe it's between 9 a.m. and 6 p.m. It's written on there somewhere. So that's tomorrow and Wednesday. I don't even see the time, but it is between 9 a.m. and 6 p.m. Yeah, there it is. The time's up here, 9 a.m. and 6 p.m. So if you still don't have a graphing calculator, you need one for this semester. Next semester, not so much. It will make it easier, but you don't have to have one. You must have one this semester. If you don't have one, we rent them for $20 per semester. However, if you are a junior and going to take calculus, you should probably buy one because you need one in calculus. If you're going to college to take math and going to take math, then you need one also. So real quick, all of these are up here if you need a calculator. Class resources. Your homework for today is already up here. Here's what the homework is. Those were the notes, by the way. I'm just showing you guys. You only have 8 questions and it's all right here. Some people have asked me, where's the homework? So there you go, and you can see how to do this, all right? So we've got some graphing, we've got some evaluating over here, we've got some graphing. So you guys have 2 pages. Your second page is right here, all right? Get this done. By the way, I will not be here tomorrow. So my daughter has something that I need to be home for. So I won't be here tomorrow, but so the screen, you will have a small video to watch or lesson. So go through and try some more. And if you have questions, I'll go over it on Wednesday. All right. By the way, back to school night. Back to school night is tonight starting at 7 o'clock. Please provide your parents this link. So this Zoom link is the same one that I'm going to be using. Okay. So provide that to your parents and hopefully I won't say anything bad, I promise. In fact, I think you guys have done a great job. One thing I'm asking you both personally and professionally and with your parents, also tell them, so I'm getting literally about 40 to 50 emails a day. That's a ton of emails. So I try and answer all of them, but I realize sometimes I'm only getting like 15, 20, 30 emails knocked out, like responding to them a day. Now, if I'm getting that many, those bottom 10, sometimes I just either haven't seen them or forget to go back and look at them, whatever it is. So stay on top of it. So if you ask me a question and I don't get back with you within 24 hours, remember, I'm going to cut you guys as much slack as possible. I also kind of am requesting the same. Just email me again. And the second time, if I still don't answer within 24 hours, then that's on me. That's my bad. But make sure you guys ask questions, and I will. I promise you I'll get back with you guys. All right? Anybody have any questions?
Do we need to log on to Zoom tomorrow since you're not gonna be here, or do we just have to like go to your?
No, and you guys don't have to go on to Zoom tomorrow. Just get on my Canvas page, and it'll give you instructions, either a worksheet or whatever it is that I have for you guys. So I haven't figured out what exactly I'm doing with you. It might be a small video. It might just be some more practice. All right? All right. Then we are finished. Have a fantastic day. See you guys.